right. Get myself organized here. Super. Good morning, everyone, and thank you, Monica. I'll get straight to it because we've got short time here. Fire regimes and the ecological role of fire in U.S. landscapes. I've decided to tackle this topic short and quick with what I call Fire Ecology 5+5. I'm going to cover 5 topics that I think represent state of the science for thinking about fire ecology and hopefully get through 5 highlights of research priorities moving forward. So, state of the science 1, fire ecology's domain. It's well recognized that fire plays an integral role, an integral ecological role in ecosystems, but with different tempos in different places. And when we think about this ecological role, it plays out in many different ways. Fire is essentially combustion, the reverse of photosynthesis, and what it's doing is opening up opportunities for the dynamism of succession and the dynamism of ecosystems to progress and change over time. When we think about fire and its role as a disturbance in ecosystems, what we need to think about, and what we are thinking about today, is about too little fire, too much fire, or the wrong kind of fire, and the potential that these can put ecosystems out of their quote-unquote natural balance. When we think about examining fire's domain, we talk about fire ecology, which covers ideas of the natural and human fire history and fire effects on the environment, species, ecosystems, and landscapes. So it's a big umbrella of ideas there. It's important to think about fire as not just fire, but as fire regimes, and thinking about variability in fire regimes over space and over time. We use this definition of fire regime, which is the range of variability in fire characteristics over that given area of space and over time. And as fire ecologists, we use various questions to answer the idea of what is the fire regime. These questions are: how often does a location burn? Where in the vegetation does it burn? What caused the fire? Jennifer spent some time thinking about that element specifically. How large of an area is affected? And how much biomass was consumed? What was the pattern? The continuation of that question is: how much was left behind? Seasonality. When in the year did the fire occur? So those are basic characteristics, or basic dimensions of that multidimensional beast we call fire regime, just to get us all on the same stage. And this, in terms of state of the science, that's our basic understanding, the basic lingo and the basic ideas that we use for thinking about fire regimes. So it's not just fire, we're thinking about fire regimes, and we need to be tending to thinking about temporal heterogeneity in those fire regimes. We need to think about the historical range of variability in these fire regimes. Today we're thinking about how contemporary range of variability in those characteristics differs from historical range of variability. We can consider a deeper historical range of variability back through thousands, millions of years, a time period over which fire has been involved in Earth's system, but though that might not be of acute necessity for thinking about management concerns today. And we're also thinking about future range of variability. We play this out spatially, and what I have here is a map illustrating, same map that Jennifer had actually, helpfully enough, a map of historical fire regimes. The take-home part of this map is to illustrate the different colors in different parts of the conterminous United States. Apologies, no Alaska, no islands included here. And what the illustration is that there are different types, different tempos, different fire regimes, and we've grouped them by different colors, or we haven't, or I haven't, someone else has, to illustrate the variability in fire regimes that we think occurred in historical times. It's helpful to take those maps and then to look at the pictures of these types. Here are some basic groupings. I think of, under that notion of historical fire regimes that are normal and have helped to develop the ecosystems that we have had over the last hundreds of years. Frequent surface fires in grasslands, for example. Frequent surface fires in dry forests are what are considered to be the historical norm. Infrequent crown fires in wet and cool forests are also within that domain of within the historical range of variability, and it's useful and important to realize that there is a place for those stand replacing fires. And moderate to frequent fires, crown fires in shrub and chaparral. Mosaics. Fire is not just fire. Again, within a fire, We see variability. Fires may be dominated by some of these characteristics, but there is structural and spatial heterogeneity. Often when we think about the idea of a fire mosaic, we narrow in on this idea of the term fire severity, which is organic matter lost from burning, including soil and vegetation components. Map on the left there, yes, your left too, is one of fire severity based on Landsat data, which is at a 30-meter resolution, illustrating relative variability in the degree of biomass change. You can see a picture of the right of what that actually looks like in real life. But the important partner, the yang to that yin of fire severity, are fire legacies. What is left behind, what persists through fire, as seed banks, standing live and dead vegetation, carbon pools, resprouting capacity. And we think of these structural, thank you, and life history adaptations as ecological memory. These are the ecological memories that help an ecosystem return back home. I'll probably only get to my 5 state of the sciences, and we'll have to talk about research priorities later, as I've seen 2 minutes. Ecological response to fire. When we think about the ecological response to fire, we have to remember that fire is one factor in the environmental niche of a species, and an important one, contributing to where species occur, persist, and reproduce. Living things have adaptations that enable them to persist within a given fire regime, those historical fire regimes that I showed images of. This historical fire acts as a filter. Organisms are well adapted to or even dependent on certain types of fire. And we consider these to be fire regime adaptive traits. A useful image to think about when we're identifying these ideas of matches between fire regimes and the ecosystems and the ecosystem members, the membership within those, the biotic membership within those ecosystems, is this box-in-box diagram, where the necessity of safe operating space for fire regimes and biota is where the fire regime adaptive traits match quite well with the characteristics of the box of fire regime. I'll finish off. Well, I wanted to show a number of images of different fire regime adaptive traits. Your eyes can wander through them on your own, other than to say that there are numerous ways in which fire species are well adapted to the fire regimes that they've experienced over time. That's why they're there. And when we think about safe operating space, it's when the adaptive capacity of species matches with fire regimes. I'll leave us off here. Our question for today, in many ways, in many factors, is: are we leaving safe operating space? To what degree is contemporary management and ongoing climate change generating a mismatch between ecological communities and fire regimes? Thank you.